and welcome to another episode of What We Can't Not Talk About, the podcast of the Austin Institute for the Study of Family and Culture. It's a pleasure, it's a delight to be back on the podcast. It is a delight also to speak once again with an old friend. So, among the things that we can't not talk about, there is for sure one, and that is artificial intelligence. Everyone is talking about it. Some people are very excited. Some people are scared. A lot of the people in academia are very skeptical. They're afraid of the effects that artificial intelligence can have on what we teach, how we teach, what people learn, and how we all learn. So to do this today, to talk about artificial intelligence with you all, I've invited an old friend, and it's another Italian. It's not the first time I invite Italians here, but we've had very good ones. So hoping that you will all forgive our foreign accents, but I know you do. And I know you love foreign accents. I would like to start with why him? Why did I invite Carlo Martinucci on our podcast? So, Carlo, first of all, welcome on the show.
Thank you, Marianne.
Why don't you tell us and our audience more about yourself? And most especially, I would say why, as of late, you're tirelessly studying artificial intelligence, talking about it, writing about it.
Well, thank you so much for having me. So I hope it will be a useful conversation for you. So I am a mathematician. I graduated 10 or something more years ago in Ferrara, which is my hometown. Doesn't matter. But actually, then I moved to Padova, where actually I met you, Marianne, 10 or something years ago. And I moved there to start my PhD in mathematics. And it's nice because I had some big ideas of doing some big academic work and discovering some theorems, some stuff like that. But nothing of that actually happened because I dropped out from my PhD 2 years later. And I decided to pursue something which I had no idea at the time, but I had just a little bit of hype and enthusiasm about, which was like programming. And so I moved on to become a software engineer. And that was really nice because I discovered one passion, and I worked as a software engineer for many years up until just a few months ago. And at the beginning of this year, 2025, I decided to part ways with my last company without having another job to do, just because I wanted to study AI in a focused way. So I spent my last 9 months or so basically studying it and pursuing other interests.
Okay, I want to say one thing here. This is what I learned from my PhD supervisor, and I think you're embodying what we try to form here, which are truth seekers. And truth seekers are people that engage with ideas and dedicate time to them. So this is a very crazy choice. I mean, people are leaving a job. You also have 3, almost 4 kids, right? I know the 4th one is coming, and you're young. You decided to abandon your profession and study deeper something that you think is very important, right? So why artificial intelligence? Well, what made you think this is where your energies should go now?
Yeah, well, you said it at the beginning. AI is something for which some of us feel a great excitement and others great fear. And for me, the two things goes together. I am really, really excited about AI, and I am really, really worried about it at the same time. I've always loved science fiction. I read a lot of Asimov and but that was something that was really a big fascination for me. And let me tell you this about science fiction, because it's something that not everyone knows. I think that most of us who love science fiction doesn't really love big explosions or you know big
Gigantic spaceships.
yeah, no, I mean big TV movies like Transformers. They're amazing, like Michael Bay, amazing, but that's not the core of science fiction. The core of science fiction is just taking something which is futuristic and using logic and social sciences in some sense to draw all the conclusions of that different situation. Science fiction is about us, is about human beings in different conditions, in different situations, in futuristic scenarios, but it's about us. And I think that artificial intelligence is um, a big part of the fascination that we have for artificial intelligence is that it's about us in the end, how it's made and how we try to understand it is using human categories. And we talk about is it conscious and a bit conscience is something that is something that belongs to us, and is it intelligence in the sense of human intelligence? And I think this is a big part of the fascination. And the other reason is that I started reading authors like Nick Bostrom, Eliezer Yudkowsky, and others who was the first to ring the bell about the fact that AI could go horribly wrong. And that was my first call and the first reason why I started looking into it, trying to understand the big potentials on one hand, but also why and how to prevent it to go horribly wrong.
Okay, let's keep this in mind, right? It could go wrong. It could go horribly wrong, which also means it could not. And I would love to explore these scenarios in a moment. But what I would like for us to do, which I found really helpful that you did in another conference that you hosted in Italy, you guided the audience, right, through what even are we talking about? Because true, part of our audience are computer science students that are totally familiar with what you're talking about and machine learning. But a lot of us, me included, are kind of a hard time understanding how we go from giving some data to a machine to having a risk for humanity in the future. So why don't you guide us a little bit through what are we talking about when we talk about artificial intelligence? What about it is the danger?
Yeah, with pleasure. So at the beginning, there is the algorithm, and
In the beginning, there was okay. We start from there. Okay.
yeah, because when you speak about algorithm, you think it's something magical, something that you don't know about, and yeah, the definition of something that an engineer tells you and doesn't want to explain you about, but it's just a joke. But actually, an algorithm is something that it's the complete opposite of that. The algorithm is just a finite procedure that given some input gives you reliably some output, and some numerical algorithms, the algorithm that we are dealing with are something that in principle you could just take pen and paper and do some calculations and start at the beginning with some numbers and end up with some other numbers. And the core of artificial intelligence, how we know it today, like LLM, large language models, is just a straightforward algorithm, which only problem is that it's really big. So um, to guide you through the procedure, what happens when you hit the submit of your preferred chatbot? You prefer the AI chatbot.
Yeah.
What happens is that your text goes to some server in some data warehouse somewhere, and goes into a machine. And in that machine, an algorithm is performed multiple times. And what happens is that your words becomes some numbers, and the numbers are taken and multiplied with other numbers and summed up together, and then multiplied in another way in big rows and columns of number that are called matrices, and matrices get multiplied together in a way that a first year student of any scientific discipline can tell you about, because it's linear algebra, which is something actually very basic, matrix multiplications. And the only real mystery in that is that there are so many computations that it's not humanly even conceivable to actually do them. But what happens is just that, and in particular, what happens is that this LLM, this algorithm, is just something that starting from a sequence of words, of tokens is the term, but we can think of words, predicts and output you the next one that is most probable to follow from the first words that you gave it. And in order to do that, you perform an awful lot of matrix multiplications. And when I say a lot of them, I'm talking about GPT 3.5, which was the first one to make some hype. It was something like hundreds of million of parameters, which means, roughly speaking, hundreds of millions of multiplications and sums. So yes, in principle, you could take pen and paper and do that. It's unfeasible. While a machine with our hardware now can actually do them, and every time it just gives you the next word, the next token, and you do that as long as it takes to get an answer. And but the question is, okay, you go through this algorithm and there is nothing magical about it, because as I said, it's just multiplications sums of numbers. But what's magical about it is it's that the result is something which makes sense, and in some sense it's something that's really surprising, right? So the question is, how do you decide what kind of multiplications and what kind of sums you make? And this is determined by the parameters, as we were saying, of the model. And we were talking about hundreds of millions of parameters for GPT 3.5. We're talking about trillions of parameters for GPT 5, the last one from OpenAI. But I mean, frontier models are about trillions of parameters.
Can you explain it to someone who's really, really ignorant in this field? When you talk about parameters, what are these? Like, I kind of have an intuition of what you're trying to tell me, but like all these equations, does someone writes this equation, or does the machine write these algorithms on its own? Like, how does a machine know how to process the information?
Yeah, so the structure of the algorithm is something that you give to the machine. And that's very, very important. It's a form of a neural network, so it's a form of way of actually, it tells you what kind of numbers you have to multiply and what kind of other operations you have to make. But all this operation relies on some parameters. So for instance, a very, very simple example, let's say that you have two numbers and you want to get another one, and you have to multiply the first one with some parameter, and you want to multiply the second one with another parameter, and then you want to sum them together, and then you want to make another operation. Now, what are those two numbers that you want to multiply these two numbers with? Are the parameters. In this completely useless network, which is it's not even a network. You just have two parameters, which are the two numbers that you multiply with your input to get your result, and then you sum them together to get your result. So it's useless, because having just two parameters is not something that you actually need anything to do with. But when you actually have something very, very, very big, and we're talking trillions of parameters, then something happens. And the structure of this network, so how you actually combine this number together, your input and this parameter together, is very important, and one of the breakthrough that allowed the current generations of LLM is called the transformer, not the movie this time, but just a way of rearranging the nodes. So a way of how to multiply these numbers together.
Okay.
It's very particular. It's called transformer. It has some features to it, but in the end, it's just a way to arrange the numbers and the parameters in order to multiply those matrices together.
So is it kind of a probability that the algorithm is saying, it's probable that this is the answer to the question? Is the most probable answer is this one? Or
Kind of. So in order to answer properly to your question,
yeah.
I tell you how these parameters are actually
Yes, please.
found.
Go with the order. Yeah.
So the idea is you want to train the model, and that's the technical term. And in order to train the model, basically you start from random parameters, and then you do what's called the backward propagation. And what does it mean? It means that let's say that you want the model to learn I don't know, Dante, the Divine Comedy. You want it to learn some text, and you can give him the beginning of the text, and the output will be a random output, because obviously there are random parameters, so the output will be random. But then you know what you know how it goes on, so you know how far how big the error of this random answer is with respect to the actual answer that you wanted to, so the actual word that you wanted. And using this difference between the actual word that you wanted and the one that you got, you can propagate back the correct answer, changing the parameters such that if you run the algorithm again, then it's more probable that the answer is more close to the correct one. So you
could a practical example be? You say kind of a number of women, and another question being, what do they desire to do in a summer afternoon on Sunday? Right. And then what the truth is of out of surveys.
Yep.
Say. And then so can you is a possible goal that of creating an algorithm that is basically gonna give random answers until the answer is like actually what the women said they like to do on an afternoon in the summer. Is that reasonable? Like, is that a possible application? Like, you give them a question, but you check back with the reality what the answer is, which is why I would understand I'm giving data, but just staying where I am, telling the machine what I buy, telling the machine how much I walk per day. Like, these are all data that would actually feed this algorithm, this machine.
Yes, absolutely, yes.
Okay. So I think I got it. Wow. I hope that our audience did too. But I think that this example made it kind of clear to me.
Yeah, and the interesting thing is that if you do it right, well, if you do it right is if you train the model with this kind of questions, the model doesn't just learn the answers; it also learns how to pose the questions. Because if you don't give it just the final part, but you give it everything, it will also learn how to ask the questions, not just the answers. Okay, so when I'm saying learn in this term, learn again is a human term. So we are saying that models learn something what's actually maybe a little bit more precise is that the model starts predicting things, start behaving in a way that is more similar to what you gave it. But then, and this is where the miracle happened, you would expect, if you didn't know, if you don't know, were born like 50 years ago, no, I mean 50 is not enough, but maybe 100 years ago, and you could explain this to someone. It's really hard to predict that this method is actually able to generalize outside of the training data, because this is the big point. It's not correct to downplay modern AI as just a statistical device that is
Okay.
only able to give you the mean or the average of all that it learned, because it's not actually true. Like, what happens when you have a really huge model, and GPT 3.5 was the first one that started to exhibit this kind of behavior. What happens is it's that it generalizes outside of of its distribution. It starts to give you correct answers, not just for the data that it saw, but also for data that it didn't see, and not just factual answers that you could I don't know, like if you have some statistical data, you can say, okay, I learned that the correct pattern is a line, so I can learn out of the distribution. But this is not just statistical data in the sense of points on a graph. These are actual language constructs that somehow reflect some kind of reality, you know. So the fact that the model learns outside of the distribution is its first real feature that makes us think that there is something here, and it's not just some stochastic parrot, as someone calls it.
You call it a mystery. I've watched, after talking to you, I did look into some, experts and like some famous people. I'm trying to look for the name. Who was the guy? Um, that was suggested to me as someone who was not skeptical, but then in the latest interview he did 7 days ago, let me see, what's his name? Pearl? Could that be the name? Um, what's his name? Judea Pearl? Yeah, a guy that won the Turing Award, some Nobel Prizes. Like, so these guys that, in his latest interview, August 25th, that I was watching, is like, oh yeah, I totally agree with the idea that human beings could become artificial intelligence pets, which scared me. Um, it scared me because it proved wrong some of the theories you were explaining to me when we last talked. And also the reason it scared me was that, again, this man had been mentioned to me as someone who was not worried about AI. And so knowing that he said that a couple of weeks ago, um, I mean, gave me pause at the very least. So what we said earlier is that you say, I mean, unless we want to continue with like the what artificial intelligence is, but I think we can go back there. It's like when we say it could go wrong, right? So what are the possible scenarios of like how this artificial intelligence could develop? And I think we did, anticipate that there are like three major views of how things could go.
Yeah, so yeah, there are a few different ways that expert people thinks about what could happen, and the less threatening one is called AI as normal technology. Is the name of an article that was written by Arvind Narayan and Sayash Kapoor. I hope that I pronounced the name correctly. And the idea is, for them, the idea is normal technology is somehow a misleading name. They don't mean normal technology in the sense that it's not important or it's not destructive, but they say the big effects and of AI are not in the technology in itself, but in how society adapts to them and how society reacts to that. And since society changes in society are quite slow in the sense that industrial revolution wasn't so slow, but in some sense it was still slow in the sense that it needed time to adapt. Then the kind of problems and the kind of things that we should do in order to react correctly to artificial intelligence are things that are related to society. And right now, frontier models are as good as a graduate, let's say, something just out of university, maybe, at coding. But as capabilities increase, then AI will start getting better at those things. And it will start getting better also at the job that AI engineers do. And in the big companies, there are plenty of AI engineers that work tirelessly to advance the capabilities of AI. But once AI becomes good as the best of them, then the best AI companies will have hordes of AI engineers, artificial AI engineers that will be able to advance AI further. And in the AI 2027 scenario, sooner or later it will happen. Maybe it will happen in 2027. Maybe it will happen a little bit later. But when it happens, then there will be some boom, some intelligence explosion.
Okay.
It will still be gradual, but it will be quick. So
Okay.
we will eventually, probably, maybe have time to react, either to shut it down or to solve the problems that
Unplug it. Yeah.
unplug it somehow. But it's not given that we will be actually able in terms of having the will to actually shut it down. And if it is not aligned and if we don't shut it down, then it's a big problem.
Aligned. Before we get to the third scenario, which is the big problem, what does aligned mean?
Well,
Not
so
aligned. We didn't talk about
when researching AI, there are basically two kind of fields. One is capabilities, and the other is alignment. Capabilities, clear, you want to improve the capabilities of the models. What exactly is alignment is not so easy to define. It's much easier to define what it means for it to not be aligned.
Okay. Let's do that.
Because when the models lie to you, when the model try to blackmail you somehow, when the model try to cheat, when the model tries to do something which is clearly harmful, then you know that it is not aligned.
Okay.
For,
Okay.
for it to actually be aligned is a very, very hard question. Also because with whom do you align it? Do you align it to the
user
of the user, of the developer, of the company that hosts the model, of the states that
sorry, and
the company is in?
it's worth mentioning. You will talk about what is the kind of ChatGPT that we should use if we ever want to use it, and we should not. But like bad artificial intelligence has led to suicide, right? So there is a non-aligned and answer, like the wrong answers given to the user, reinforcing his own beliefs. Say, right, because like we have a model that thinks that what is important is always to tell you you're right.
Yeah, so there are already some cases and also some parents who sued companies for the suicide of their children. We should be very, very careful in understanding precisely what went on in those cases. We human beings are still special, even if AI could one day become more powerful than us. Is that you don't have proofs to actually prove it to you, but you don't even have proofs to tells you that you're wrong. So it's something that's fully compatible, but completely also intangible in some way. And I think that it connects really well with one thought that I'm having recently, which is there is this concept of goalpost moving. You think that AI is powerful, but for sure it cannot do that, and then it does it, and then you think, okay, it did it, but but it cannot really do that other thing, and so you move your definition of if AI were able to do that, then I would say yes, it is conscious, but since it cannot, it's not, and then it surprises you because it succeeds, and but this introduced really to thought, which is um, can AI replace us? Well, it depends. It depends. How do we consider ourselves? How do we live our relations? So, do I think that you, Marianna, are just the host of the podcast and you are defined by your function? Well, for sure, in a few years, or maybe in a few weeks, or maybe it already happens that you could be fully replaced by an AI avatar that can speak with me and ask me thought-provoking questions and have an impeccable timing. And if I was only someone who just intervene in your podcast, I would be fully replaceable, and the AI version of Carlo would be much better than me, and probably its English would be better than mine. And I'm sorry, but the point is, if we treat other people just for the function that they have, just for what they do, then I think that AI will replace us because functions are replaceable. But the point is that, Marianna, you are more than your function. And hopefully I am more than my function. And this, who I am, who we are, our being, not our doing, this is the only thing that is not replaceable.
I think I want to close on this one. And I want to close on this one because I think this is exactly where we need to stay. It's great to write the best essay that you've ever written. Like, what is more important is that for your friends, for your teachers, for your parents, you're not a doer. And I think that it is precisely because we're confusing ourselves with our functions more and more that everywhere in the world we're having all those problems with assisted suicide and euthanasia. Right? Like, once we become unable to perform our functions, we do not exist. We do not deserve existing. So I really think, Carlo, that we should close on this notes and like having this clear understanding that what we care about is the essence that is in front of us, the person that is in front of us, the unique mixture of things that are non-numbers that someone inputted, unless one believes that that's the way God created us, which one day maybe we will know. I do want to say that I've not lost my faith, but one thing that it made me smile as I thought that C.S. Lewis' books on miracles is probably a very helpful one when you have this kind of doubts. It's like sometimes you get so Like, well, but anything could be possible. Yeah, and then there are miracles, like, and miracles are a pretty good example. Now, could artificial intelligence also make me think that I'm seeing things that I'm not seeing? Probably so. I don't know. Is there anything that we left out that you think is important for our audience to know? Um, yeah, any final thought besides this amazing thing you just said?
Probably a lot of things, but yeah, I think I'm good with this.
You think it's enough for this time?
Yeah.
Yeah, I think I did learn something. I hope our audience learned something too. I would invite them, for this time especially, to let us know with comments if there are things that should be explained better, if there are topics that we should address. I know that we have a good, following with our computer science students and our engineers, and maybe they have something to teach us. So I do look forward to hearing your comments. And again, Carlo, I want to thank you. And to everyone, is just an appointment to our next episode. And thank you for listening to us. So please, if you like this episode, like it on YouTube, on Facebook, on Instagram, share with your friends. Thank you.
Thank you so much.